तो गाइस ये प्रेजेंटेशन शुरू हो रही है अभी। ये हमारे ग्रुप वाले बैठे हैं सारे पीछे।
Everyone to the Australian Space Discovery Centre. My name is Max. I'm a space communicator here. We've done a really cool job of getting to talk to you all about space. So one really cool thing about where we are today, this is actually the headquarters of the Australian Space Agency. So right here in this building, we have our own Australian space agents. So like NASA or the European Space Agency, ESA, they're based right here in this building. So really cool that we have them here in Adelaide, not in Canberra or Sydney or Melbourne. And you can actually visit the building that they're in, walk around the ground floor, have a look at all of our exhibits. We're also meeting today on the lands of the Kaurna people, and I'd like to acknowledge them as the traditional owners of this land and pay my respects to their elders, both past and present. So the Australian Space Agency has a pretty cool logo. It's in the shape of Australia, but it's also made up of all these little dots. Does anyone know what these little dots might be? Any guesses? No one? Alright, these little dots are, we call them constellations. So they're images that we can make up out of the stars in our night sky. And all of these constellations are really cool because they're actually from our First Nations people. Our First Nations people were some of the world's first astronomers. One I like to point out is the emu in the sky up here. This one's really cool. It's not actually made up of the stars, it's made up of the dark spaces in between those stars. And this one will rotate in our night sky as the year goes on. And our First Nations people would use that to figure out when it was time to collect emu eggs throughout the year. So a really important one. Alright, does everyone like games? Yep, up the back, awesome. Today we're going to play a game. It's called Space, Fact or Fiction. So how this is going to work, I'm going to put up a statement on the screen, I'll count down 3, 2, 1, then I want everyone to scream out whether you think it's fact or if you think it's fiction. Alright? Hopefully there'll be a bit of a mix in the answers, hopefully you won't know all of them. I want everyone to get on board, no sitting on the fence, no screaming out faction, everyone pick fact or fiction and scream it out. Alright, we'll start off with an easy one. Hopefully everyone can get this, a bit of a warm up. The moon is made of cheese.
Fiction.
Alright, everyone fiction. Great work, it's a good start, everyone got that one. The moon is sadly not made of cheese. I think that would be pretty cool if it was. It's actually, the surface of the moon is something we call, yeah, do you have a question?
No, it's just a comment.
Yeah, that's alright.
If the moon was made of cheese, people would probably eat it when they down there.
100%. I definitely would eat it. The surface of the moon is made up of something called lunar regolith. So we call it lunar regolith. It's a bunch of different materials. It's actually pretty annoying for things like rovers and robotics. It causes a lot of damage to them. So it's something engineers need to pay a lot of attention to when they're thinking about putting things on the moon. Alright, onto a bit of a harder one. Space is 100 kilometers away. In 3, 2, 1. So one factor about that, and you'll be right. It's actually pretty amazing how close space is. Think about it.
Like way more far.
Yeah, so that's actually closer to us than Melbourne is. It's actually even closer than Kangaroo Island is. Pretty amazing how close space is to us. And with how close it is, we're actually quite reliant on heaps of different space technologies. So I don't know if anyone used GPS to get here today. Show of hands. Yeah. Has anyone paid for something with a credit card today? Yeah, you over here. Anyone check the weather on their phone today?
Yeah, we do.
Yeah. Right. So we all use these different services every day, and we actually rely on space technology to do that. Space is really close to us. Satellites that are in space are really important to us. It's pretty cool to think about how much it plays a role in our everyday lives. The International Space Station is Earth's biggest satellite. 3, 2, 1.
Fact.
Bit of a mix, couple facts, couple fictions. This one is fiction. Does everyone know what the definition of a satellite is? Any guesses?
Body orbiting something.
Yeah, you're very close. So
Probably moon.
a satellite is an object or a body orbiting or going around a larger object. So with that definition in mind, does anyone have a guess what Earth's biggest satellite could be?
The moon.
Moon, yeah, you're spot
Yeah,
on.
you're right. Yeah.
So, International Space Station is pretty big, 110 meters across. The moon is much bigger than that, 3,500 kilometers. That's Earth's biggest satellites. These days, we have satellites that are this big. These are called a CubeSat. Very inventive name, satellite is a cube, we call it a CubeSat. This is an example of one that's 10 by 10 by 10 centimeters. The reason we make them this size, it's the smallest object that we can track in space. So our atmosphere has a lot of noise. We're trying to send a signal up to space or back down to Earth. Something this size is sort of the smallest we can track. Anything else gets lost. Is that a question?
Yeah. Is that a real one or what?
It's not real. It doesn't have anything inside of it, but this is pretty much exactly what one would look like. A bunch of solar panels around it, little holes in it for a sensor like a camera, maybe a UV or infrared sensor. Pretty amazing the technology that we can pack into something like this. And they're also really accessible. So a university in New Zealand made one of them, sends it up into space. So pretty amazing that really anyone can make their own satellite these days and send it up into space. It's also become a lot cheaper to send things up into space. So pretty cool the technology that we have with space these days. This one's a bit of a weird one. You pee out your bones in space. In 3, 2, 1.
Fiction. Fact.
Mostly fiction, kind of called facts.
Fiction.
This one's a fact. It's a bit of a weird explanation for this one. So, when you're in space, does anyone know why you float around? Yeah?
Gravity.
Yeah. So, it's because there's lower gravity, or what we call microgravity conditions. There's not technically zero gravity. You're in something called a constant free fall. So when that happens, you're under what's called microgravity conditions, you start to float around. When you're on Earth, you constantly have gravity pushing you into the ground. So even when you're sitting in your chairs like you are now, the muscles in your back, neck, legs are constantly working to keep yourself upright. You don't really realize it, but it's always happening. When you're in space and you don't have that gravity pushing you into the ground, those muscles aren't working anymore. And what happens is they start to degrade really quickly. And so do your bones as well. And then the calcium in your bones comes out in your urine. So that's why you technically pee out your bones when you're in space. But pretty amazing how quickly our bodies start to degrade without gravity. So our astronauts rely on really amazing nutritionists to make sure they're eating enough food and the right foods, and also really amazing personal trainers to make sure they're exercising and keeping their bodies right so that they can move around when they come back down to Earth. So it's recommended that astronauts do around 6 to 7 hours of exercise a day, and that's just to stay the same, to maintain their muscle mass. I don't know if anyone could imagine doing 6 hours of exercise every day just to stay the same. I definitely couldn't. Does not sound like fun. Astronauts don't either. They do around 2 hours, and that just makes it so they can move. They can stay upright when they get back down to Earth. So if you've ever seen a video of an astronaut coming back down to Earth, they'll often be on crutches or have someone helping them walk, or sometimes they're even in a wheelchair. And that's just because of how much their muscles have degraded over that time. We use the same propulsion system as TIE fighters. Has everyone seen Star Wars? Yeah? Awesome. Alright, 3, 2, 1.
Fact. Fiction.
Couple of facts up the back. Yeah, I guess fiction up the front. This one's pretty cool. It's fact. And the really cool thing about this, the first ever, I'll explain what it is first. The TIE in TIE Fighter stands for Twin Ion Engine. So ion engines are actually the most common propulsion system used in space for satellites. So this is the first ion engine ever used. This was on NASA's, ever used in space. This is on NASA's Deep Space One mission in the 90s. So really cool that Star Wars actually came up with the idea first. Science fiction influenced real engineering and created something really important for our satellites. So they're a pretty amazing propulsion system. They work by ionizing an element and then using electricity or magnets to accelerate it really quickly. And they're pretty amazing because the propellant is so light. So when we launch a rocket, the most of that rocket is actually, the most of the weight of that rocket is fuel. Right? So these aren't great to send up something like a rocket, but they're pretty amazing in space when there's no gravity against the sun. They're pretty important propulsion systems. We know of a planet entirely inhabited by robots. 3, 2, 1.
Fiction.
There's fiction from everyone. This one's a fact.
This is the fact.
Does anyone have a guess what this planet might be?
Mars.
Yes, right.
Mars.
It's Mars. So we don't know of any natural life on Mars, but there are quite a few robots that we have put there. So these are all of NASA's rovers. There was also a Chinese rover that's sadly no longer operational. But these are all pretty amazing pieces of engineering. And I love to point out these two, Spirit and Opportunity. Their planned mission timelines were only 90 days. And they both lasted much longer than that. Spirit went 6 years, Opportunity 14. So pretty amazing how long they were operational when they were only planned to be used for 90 days. Also love these two up here. These are the newest, and kind of like the Batman and Robin of Mars. This little guy, Ingenuity, would fly out. It's a drone on Mars, pretty cool, just to think that we could do that, put a drone on another planet. That would collect a heap of photos and different samples, fly back, and recharge, and deliver all the data to the rover. Sadly, this little guy is no longer flying. It ran into something, one of its rotors got damaged. But again, it was only planned to do 10 flights and did around 70. So, again, some really amazing engineering that went into these. Astronomers knew that Neptune existed before they saw it. In 3, 2, 1. That one was a bit of a mix. It's good. This one's a fact as well. Does anyone have any idea how they might have done this? Any guesses? This one's pretty cool. Maths. I know a lot of people don't like maths, but pretty amazing what we can use it for. The way astronomers did this, they were tracking all the orbits of different planets in our solar system and realized that they weren't quite going where they expected them to go. There was some other mass, some other object in our solar system, so pulling them off of that path. And then they used maths, figured out where they thought it would be sitting, had a look there, and lo and behold, we had another planet in our solar system in Neptune. Pretty amazing use of maths and physics to figure that out. This last one might be a little bit easier. Space around Earth is empty. Is this fact or fiction? In 3, 2, 1. Mostly fiction's there. That's good. What's in the space around Earth? Any guesses? Satellites up the front? Yes, satellites. Another guess? What was that one? Troposphere. That's part of the atmosphere. But what's in the space around our Earth, so outside of the atmosphere?
Planets.
Different planets, a little closer, so you're really good with satellites. There's one more I'm looking for. Yep.
The moon.
The moon, a little closer to Earth than that. Yep.
The sun.
The sun's further than the moon. Alright, the other big one is space junk. Right. That's really important. So right now, in our orbit, so orbiting around the Earth, we have around 30,000 objects that are 10 centimeters or bigger. So about that size or bigger. And if you've had a chance to have a look in our gallery, we have a really cool table in there that tracks all the objects that are that size or bigger. You can have a look at them. Pretty amazing how many things there are. And if you haven't had a chance to look at that, I'd definitely recommend checking it out after this. But around 30,000 objects. When we go smaller than that, so between 10 centimeters and 1 centimeter, it's estimated there's around 1 million objects in our world. And then even smaller than 1 centimeter, it's around 130 million objects. And you think smaller than a centimeter, not that big a deal. We actually had a paint fleck hit the International Space Station and put a pretty sizable dent inside of it. So that's just because of how fast things are moving when they're in space. So in orbit, objects are moving at thousands of kilometers per second. Really quickly, even something as small as a pancake can cause a lot of damage. So when anything collides in space, it fragments, creates a lot more space junk. That's something that we really need to pay attention to. It's like I spoke about earlier, we're actually really reliant on different space technologies. Everyone in here, I think, used some sort of space technology today. So we need to make sure that we're preserving the space around our Earth, making sure we don't fill it with space junk so we can still use that area. It's another job to do with space we really need to pay attention to. It sort of leads me into this next slide. Pretty cool slide, I think. Shows all the different career paths that you could follow that have something to do with space. So when you think of a space job, your mind usually goes to astronaut, astrophysics, a rocket scientist, maybe an engineer. Those are the main ones that come to mind. Well, we sort of want to show you that you can take pretty much any career, put space in front of it, and it's actually a real job. All right? Pretty amazing. So when I talk about sending satellites up into space, sometimes they can hit each other and cause a lot of damage. Who's at fault for that sort of thing? We actually need something like a space lawyer to figure that out. It's not a job you usually think of, but lawyers can get involved in a space career. We actually have Prada fashion designers designing the new spacesuits for NASA. So even fashion designers can get involved in space. Do you have a question?
Why would you need intelligent game development?
So, I'll actually talk about that a bit more. We'll get into it now. We have something really cool behind the glass here. That's the one button. Behind this glass here is a private company called Sabre Astronautics. So this is actually the first viewable mission control in the southern hemisphere. So if you've ever watched a movie of a bunch of really stressed out people launching a rocket, sitting in a room like this, bunch of computers, this is the same sort of thing, except these guys don't launch rockets, they're constantly monitoring satellites. So to answer your question up the back, the reason why game development is really important, these guys actually use game-like software to control satellites. So they've developed their own game-like software, and they control satellites like you would a game, a video game on your computer with WASD. Pretty amazing work that they do here. So that grey square on the back, that's a satellite called Blue Walker 3 that gives remote communications to your phones in the US. So if you're ever out in the middle of nowhere, you need to make a satellite phone call, that's the kind of satellite that will do that. And these guys control that satellite, make sure it's in the right place, make sure it's not going to hit anything, and make sure nothing else is going to hit. So these guys do some pretty amazing work, and yeah.
Is it actually happening right now?
Yeah, it's actually happening right
behind
now.
that window?
Yeah, so these guys are all here. They're real people, and that screen is where the satellite is currently sitting above Earth. So pretty cool that we have these guys here and you can watch them working in real time. So there's also another office in Denver, Colorado, and one in Barcelona. So they work in 8-hour shifts throughout the day, make sure they cover the full 24 hours. So they work in different spots around the world, so they're working during daylight. But pretty cool that we have these guys here. You can have a look at them. But that is all from me today. Thank you all for hanging around and listening. If you have any more questions, feel free to grab any of us in the blue shirt. We'd love to answer your questions, love to talk about space. But if you haven't had a chance to check out the gallery yet, definitely go and do that. But thank you all for hanging around.
Does that mean like there were some like rocks around that it will hit something, or what?
Could mean. I'm not sure. I haven't worked in that.
I don't know.
So I'm not sure what the different alerts would be. But yeah, it's a good question. It definitely could.
So it's just one satellite which we have, or we have both of them?
Australia has multiple. That's just the one that these guys control. It's not actually an Australian satellite. It's contracted.
Like outsourcing.
Yeah. So yeah, these guys, they have an office in Denver. So we're working on
That's my next question, like why Barcelona?
yeah, so
The
that's
things belong to us.
just to make sure 8 hours every
Yeah. So how our satellites are input, they are being monitored by us, or again it's someone else?
So it depends. Some companies that make the satellites have the capability to monitor it themselves. Others don't, and they contract it out to a company like this. So it really depends on what their capability is.
And like the space head office for Australia, where is it? There must be a main head office
That
for
agency, it's in this building.
in this building.
Yeah.
Okay.
So they're
In Australia, in South Australia.
more focused on legislation and sort of keeping space rules up. They don't do a lot of the engineering, but they do the contract. They're getting involved with the Artemis missions, so some important like. Yeah. So we have Southern Launch in SA, and then Gilmore Space. So they're pretty close to a launch, I think. It's meant to happen sometime this year.